Ripples of Learning, Alex's Journey Through Deep Learning. On a crisp autumn afternoon, Alex, a student with a boundless curiosity for artificial intelligence, found themselves strolling through the park alongside Professor Paul, a mentor renowned not only for his expertise in deep learning but also for his ability to inject humor into the densest of topics. Professor Paul, Alex began, as they meandered along a path lined with golden leaf trees, I keep hearing about deep learning, but I'm struggling to grasp how it actually works. Could you enlighten me, perhaps with one of your famous analogies? Paul chuckled, adjusting his scarf against the autumn chill. Imagine deep learning as a chef learning to perfect a recipe, he started. The chef tries a new recipe, tastes the dish, this is the forward pass, and then thinks, needs more salt, this is identifying the loss, how far off the taste is from perfect. Alex nodded, intrigued by the comparison. Now, the chef needs to remember how much salt was added last time and decide how much more to add or reduce. This adjustment process is akin to backpropagation. It's where the chef, or in our case, the neural network, learns from the loss, adjusting its weights or ingredients to improve the outcome. The loss function, then, Alex ventured, is like the taste test, assessing how close the dish is to perfection? Exactly. Paul exclaimed. And just like our chef adjusts the recipe based on the taste test, in deep learning, we use the loss function to measure how far off our predictions are from the actual results. Then, through backpropagation, the network tweaks its neurons, our chef's ingredients, so the next attempt is closer to the desired outcome. They paused to admire a duck gliding across a pond, its reflection a perfect mirror image. Think of the pond as our neural network, Paul continued, seizing the teachable moment. If a stone, our data input, disturbs the surface, the ripples, the network's activations, spread out, reaching the edges, the output. If the ripples don't reach as expected, we adjust our throwing technique, this is backpropagation, tweaking the network based on the loss function's feedback. Alex laughed. So, if our chef keeps oversalting the dish, backpropagation would be like telling him to go easy on the salt shaker? Indeed, Paul grinned. And just like cooking, the more recipes, data, the chef practices with, and the more taste tests, iterations of training he performs, the better the dishes become. Deep learning networks improve by processing vast amounts of data, learning intricate patterns, and making increasingly accurate predictions. As the sun began to set, casting a warm glow over the park, Alex felt a sense of clarity. The concepts of loss functions and backpropagation, once abstract and elusive, now seemed as tangible and relatable as cooking a meal. Thanks, Professor Paul, Alex said, grateful for the insight. I'll never look at a neural network or a kitchen the same way again. Paul smiled, pleased with the day's lesson. Remember, Alex, deep learning, much like cooking, is part art, part science. It's about experimenting, adjusting, and finding the perfect balance. And sometimes, it's just as much about enjoying the process as it is about savoring the results. As they exited the park, Alex felt inspired, ready to dive deeper into the world of deep learning, equipped with new understanding and a dash of humor to lighten the journey.